Hi, today we are going to talk about a new sorting algorithm. It's called bubble sort. Let us see demo to understand how bubble sort works. So first, this bubble sort is solving the sorting problems where we have as input array of n element, and as output we are expecting to see the array sorted in non-decreasing order. Let's see a demo about bubble sort. So we get an array of numbers. Bubble sorts work as the following. It compares the first two elements. If they are not in the correct order, we swap. And then we move one step right. And then we compare the two elements. If they are not in the correct order, we swap. This swapping, in this procedure, we will always swap the largest number. So in this array, the largest number is 8. We will make sure that 8 will be the last element. So after one scan of the swaps, we are sure that the last element will be the largest element, which is 8 in this example. So after this, we can see that 8 is sorted now. And the rest of the array we need to sort again. So we go back from the beginning, we make swap. This swap procedure will make sure that the largest element will be the last one. So we compare 6 and 7, there is no swap here. 7 and 2, 7 will come here, there will be a swap, and 7 and 4, 7 will come here, and so on. So this swapping procedure is sorting one element for every scan. And actually we need n minus 1 scans roughly to sort all the elements. So this n minus 1 scans, every scan we need around n minus 1 comparison. So the first time we need n minus 1 comparison, next time n minus 2, and so on. So the running time we will discuss in a minute. It will be n square because of this. Why we call it bubble sort? Because this large element, it's like in the bubble, and with every operation it's moving up like a bubble to the correct location. So with this, now we sorted 5, and then you can easily see that there will be one swap here, but 3 and 4 there will be no swap, so 4 will be sorted, and so on till we sort the array. So to see the code, in the code we will write a code in a minute. We have like for loop. Inside this for loop, each iteration in the outer for loop is for every scan. So we keep scanning n minus 2 times, okay, or n minus 1 times, from 0 to n minus 2, which is n minus 1 times. For every scan, we do the swapping. We start from the beginning till the last element, which is unsorted. That's why we write a dot length minus I minus 1, because in the first iteration, when I is 0, we will make scan for the complete array. But later on, we will decrease because we already inserted one element at the end. So that's why we write minus I. So every iteration of the outer for will decrease this scan by 1. Inside this inner loop, we will compare a of j with a of j plus 1 to make sure if they are in the correct order or not. If they are not in the correct order, in this case we need to swap. So we do the swap using temporary variable. So the running time, we do n comparisons for the first scan, n minus 1 for second scan, n minus 2, and so on until we have one comparison or one swap in the last scan. So these behaviors give us n plus n multiplied by n plus 1 over 2. This is like n square roughly. So the worst case analysis is big O of n square. Best case analysis, The best case analysis happens when the array is already sorted, but still, using the bubble sort algorithm, you still need to compare every pair of elements, even they are sorted, and you do n-1 scans, so still it's n square. The average case is again n square. Now we have two exercises. We want to write a bubble sort method that order the integer in non-increasing order, meaning that it's the opposite order. So the largest element with the first. We just do little modification for bubble sort, and we want to improve the bubble sort so that we can have best case analysis big of n. So imagine we have a sorted array already. Can we improve the running time? So we have to compare anyway, but we have to compare only for the first scan, right? If we did the first scan and we find that there is no swap, we will know that this is sorted, right? So is there a way to modify the bubble sort so that we don't do other scans, because we know now the array is sorted? So this is the second exercise. Now let's do the coding part. So last time we did selection sort. This time I want to make a new method called bubble sort. Public static void bubble sort, and it takes array of integer. So in this bubble sort, I will loop from 0 to less than a dot length of the array, -1, because in the last scan I only have one element, so I don't need to make scan for only one element, and then I++. Inside this loop I have another loop, int j equals to 0, j less than a dot length -1, but I also need to add -i, because every time I should decrease the number of elements that I'm comparing. So, and then I write j++, and then here I have to compare if a of j less than a of or greater than, if the order is not correct, what should I do in this case? I will do swap. This is a comment. So how to do swap? I define a temp equals to a of j, and then a of j should equal a of j plus 1, and then a j plus 1 should equals to temp. So with this I swap the values. Now I finished the bubble sort method. Now in the main I created one array, and I called the method bubble sort, and I printed this array. So let's see the output. We will see that the output has not correct order. So let's see what's the problem. If a of j is greater than O of j plus 1, so we compare the element at position j with the next element, right? If the first element is greater, this means they are not in the correct order, then we do the swap. And now we have the array is sorted. Thank you very much for your listening.